Good evening, everyone. I'm Sneha Bagri from Sehat Software. I know it's been a long day, but I hope I can build in some energy so that we can be ready for the next set of talks. So, when we talk about asynchronous systems, one tool we often talk about is Kafka. It is powerful, it is popular, and it's often the default choice. But here is the truth: Kafka need not be the default choice always. Sometimes simpler systems can be faster, cheaper, and easier to maintain. In today's talk, I will walk you through how I learned that the hard way and provide a practical decision making framework for making smart async API architecture choices. A couple of years back, I was working for a fast growing e commerce company. We were using Kafka for all aspects, be it inventory, payments, customer analytics, orders. And as we were doing it, we were seeing a lot of benefit out of it, as we were able to build fast, loosely coupled systems which were real time and we could scale with ease. We were able to solve all our problems using it. It became our golden hammer. We were hammering all our problems using it. Then we got a simple new requirement where we had to automate the return process. So to automate the return process, when the customer actually announced the return, we wanted to generate the label in the background and later send it over as notification. It was a simple problem statement, and we had a default bias towards Kafka. So what we created was all around Kafka. We had our UI, on which we were clicking the return announcement button, which triggered an API, and that API in the background actually just buffered all the events and then sent a response that things are going to work in the background because we were going to do it in the background. And then the Kafka event, which was the return announcement event, was consumed by the return label generator, which then generated the label and stored it in S3. Once the label was generated, a notification message about the generation of the label was sent, which then notified the customer that things are working fine. You have got your label and you can use it. But the complexity started when we started thinking about resiliency, especially because we were dependent on an external carrier API for our label generation. And when we started doing that, we ended up creating a series of topics, rather a chain of topics. And in this case, the number of topics that we had defined the number of retries we had. Because we had our main Kafka topic, and that was being processed. Then if the return label was not correctly generated at that point in time, it went to the next retry topic. From that topic, again if it failed, it again went to the next topic. And finally, it ended up in a dead letter topic. Once it ends up in a dead letter topic, we need to have some kind of manual intervention. That means there also needs to be some alerting and monitoring mechanism where we can see what's gone wrong, fix it, and then again redrive. So as we see, just for the simple retry mechanism, we ended up maintaining like over 4 topics. And whenever we maintain something in Kafka, that means we have to manage its offset, consumer lags, partitions. A lot of configuration has to go in, which overall increases our operational overhead. And at this point, we reflected on the problem that we are seeing. So I would just like to call out the problem that we have seen so far. Whenever we hear async, our default choice is to use Kafka. And whenever we use Kafka for a simple use case, it ends up causing more pain than real value. Because as we saw just now, we were creating 4 topics just for retries, not even for the main business aspect of what we are doing. And apart from that, if we are also maintaining the Kafka cluster on our own, that means we have to manage a lot of resources, ensure it is scalable, performant, monitor it, and if it is used organization-wide, we need to ensure that the topics, data formats, guardrails, accesses, everything is defined. So there's an orchestra of things that you have to take care of. So it really complicates our life. So this is the Kafka by default anti-pattern. I would like to share few real-life examples where companies chose some other tool apart from Kafka. Simple Bet, which is a platform for micro-betting. It went ahead and used RabbitMQ over Kafka because they wanted low latency with low cost. Next, we have a cybersecurity expert called Palo Alto Networks. They completely got rid of Kafka because it was causing a lot of operational overhead. And they just chose to go with SkylarDB for all their async communication. Next, our well-known e-commerce website, Flipkart, moved away from Kafka to Apache Pulsar because they had additional requirements like multi-tenancy, geo-replication, and they also wanted to segregate the compute from storage. And if we had to build all of this with Kafka, it would mean additional code and additional heavy lifting. So they just moved to Apache Pulsar for their use case. Now, once we have identified the problem, I would like to go back to our use case and see what we really did. So in our case, once we had identified the problem, we brainstormed internally and tried to find the right tool for the right context, or what was the context and what would cause lesser pain. We went ahead with using SQS. With SQS, our life became much easier because the retries were simple, and whenever something failed, we only had to create one additional DLQ. And with the DLQ, also the alarming and alerting came out of the box, and the redrives were just one click. So this overall reduced our operational overhead. And we were able to invest time in actual development of new features, which made our business happy, and also we were saving some cost. So overall, everything became well. So at this point, I would like to point out that if we stop defaulting to the golden hammer, then we start building meaningful systems. So once we have identified the right tool for the right job, I think the big question is, how did we do that? How did we know this was the right tool that I should go with? So that's where I would like to propose a practical framework, which I give it the acronym of CHAP. It is not just some statistical comparison matrix, but it rather involves a lot of real-world nuances. First, we need to collaboratively work with our stakeholders to understand what the problem really is. Next, we cannot just pick one fancy option that we see, but we need to look at all the options holistically and decide what might be the right fit for our use case. Now, we will not just pick one option because it got rated more, but we would be adaptive and try to understand the trade-offs that selecting that tool might bring in. And finally, we have implemented our systems, and we would like to retrospect on it to make sure we see how much value it's bringing in production and what further improvement is required. Let's apply this to the return label use case we just saw. So the first step is to collaborate with the stakeholders and define both the functional and non-functional requirements. Now, each non-functional requirement we would rate on a scale of 1 to 10, where 10 is something which causes the maximum business impact. So in our case, we identified that automated and smooth customer experience was very important. And for achieving it, we required low latency and high reliability. We rated low latency at 6 and high reliability at 8. Low latency was rated lower because sometimes minor delay was acceptable. However, high reliability is given an 8 because the system needs to be available. We are okay to have sometimes delays, but it should be available for the process to happen. Next, we also need to ensure that no return request is lost. Whenever a customer clicks on the return announcement button, it should process it in the background and give a result. That's where we need to ensure resiliency and durability. Also, because our business was growing, we wanted to ensure that our system is scalable and provides high throughput. Finally, one of the most important driving factors was cost efficiency, because we wanted to bring down the operational and infra cost and invest that in building actual new features. Once we have identified the business features, we need to take a holistic view at all the tools we have in our toolbox. And for doing that, we need to put up a matrix. On one axis, we put up the tools that we would like to evaluate, and on the other, we put up the business requirements we just identified earlier. For simplicity, I'm just showing 2 tools, Kafka and SQS, but in real life, we actually evaluated 5 or 6 tools and then came to the conclusion of which one to use. Once we have these tools defined, we need to give a rating to each tool on a scale of 1 to 5, where 1 is poor and 5 is excellent. So let's say in case of scalability, we gave Kafka 4 and SQS 5. Similarly, we rated all the other business characteristics for each tool. So it ended up looking something like this. Once we have these, we need to find the weighted average of how each tool is performing against our business requirement. So basically, we are multiplying the business requirement with the tool score and then summing them up to find the final weightage of how much this tool is going to help us with our current business scenario. Now, when you do this, you will get the top 3 or 4 options as to these could be the tools that I can evaluate. But doing this doesn't really mean that you can just go with something which got the highest numeric value. You need to still take the actual environmental view. You need to understand the trade-offs that each tool might bring in and then decide on which tool you would like to use. So for doing that, we first need to identify the ecosystem fitment, wherein we need to ask ourselves, is this tool something which would integrate easily into my current ecosystem? Is there some kind of upskilling that I need to do for my team? Is there something I would need to set up new or I would need to buy? So these are things which would define if your tool is going to fit in your ecosystem. The next important thing is you also need to get first-hand experience for any tool that is new to you, because doing that will help you understand any kind of integration gaps you might have, any hidden costs, or any performance issues that might occur. So a proof of concept is really important. We also need to identify the risk, trade-offs, and assumptions, because if we know this, then we can take a more informed decision of which tool would be the right fit. So what are assumptions? Assumptions are things that we know as of now that this is the state of the system. For example, we know that a system at a max might end up churning out 250 messages per second, or we are okay with the vendor lock-in. These are assumptions we are taking. What are risks? Risks are things which are some things which can go wrong because we assumed something. For example, suddenly the business says, oh, we don't want AWS anymore. So now the vendor lock-in becomes a problem. Or we suddenly see a high surge in throughput. Our assumption was 250 messages per second, but suddenly we are seeing a surge in input. So these are risks based on which we are defining our system. And trade-offs are things which we are aware of, but we agree to it and still make that decision. For example, in most cases, I think most of us would have seen this. It's okay, we will not build a very scalable and reliable system. I just need that feature fast enough. That is the most real trade-off that we take and we go ahead. So I guess that's a known trade-off. And that's why it becomes important that at the end of things, we build alignment with our stakeholders to make them understand that this is the decision we are taking and this is the reason why we are taking. What is the reason of taking that decision? And what are the trade-offs that we are considering? This will help you build trust and ensure that there are no surprises suddenly. Okay, why did you do this? And it shouldn't have been this way. So there are lesser surprises and everybody is in a collaborative environment. So at this point, we are assuming that we have made the decision and we have identified the right tool for the right job and we have also implemented it in production. But our task doesn't end here because we also need to keep retrospecting if our system is performing what we really built it for. For doing that, we need to find out how our system is really performing. In our case, we ended up finding that we were generating duplicate labels. So the same label was getting duplication. We were basically missing idempotency. So we had to build that in. We also identified that certain messages were slowing us down. There were messages which were malformed and which was taking quite a long time to be processed, and so eventually it was slowing down our systems. These were some findings that we had, which we had to go back and retune our systems for that. We also saw the positive side of things. We had a 100% rate of label generation because we had built a scalable and resilient system. Also, our overall ops time came down, and everybody was happy. Our customers were happy, our clients were happy, and developers were happy because we were able to build features which really created business value. So everybody became happy. So at this point, I would like to reiterate that I'm not saying that Kafka shouldn't be used. Kafka is really a very powerful tool, and we can use it for the case it is really built for. If you're trying to build a low latency, high throughput system, or you need guaranteed ordering, or you want a replayable and durable storage, or you need to ensure that you're doing real-time streaming and you're able to join and aggregate as your data is flowing, then Kafka is a very good fit. But in our case, our choice of SQS gave us the only things that we were looking for was to bring down our overall operational overhead, to be cost efficient, and to be scalable enough. We were also okay with certain trade-offs because SQS gave us a little higher latency as compared to Kafka, but we were okay with that. We also knew that we were going to do a vendor lock-in, and there'll be no ways of replaying the events that have already been processed. And finally, the retention period for the messages in the SQS is only 14 days. We were aware of these facts, but these factors did not matter for our use case. So SQS was a good fit for us. So at this point, I would like to re-emphasize that no single tool should be a golden hammer. We should try to identify what is the right tool for your right context and just not go with the hype of this tool is the best and I should just use it. Everybody in the industry is using it. That's not how it works. We need to fit it back to the context and then make the choice for it. So I would like to leave you with 3 key takeaways. The first is, we really need to break that golden hammer in our minds. In our case, it was Kafka. In your case, it might be some other tool. And we need to understand that Kafka is not that one fancy tool which will help you solve all your AsyncAPI problems. The next is, we need to choose the right tool for your current context. And that's why framework like CHAP, where you will be able to collaboratively, holistically, adaptively, and practically select the right tool for yourself would really help. And finally, we need to understand that simplicity often wins and complexity is fragile. So we need to go for simpler solution and not that fancy solution that we see everywhere. Thank you.
Thank you so much, Sneha. Do we have any questions?
So it looks like we will end up using multiple tools to manage these async APIs. So do you see any issues maintaining those multiple tools in the same system?
Yeah, that's where the ecosystem fitment comes in. Okay, sorry. So the question is, if we end up using a lot of technology for async API, is there a problem with it? It really depends on the ecosystem fitment that we just saw. In our case, we were already using AWS for S3. And we had an account with AWS, so it did not cause a lot of pain because we were already with AWS, so we could go ahead with use SQS. Actually, when we rated, for us, GCP was highest rated. But we didn't go ahead with GCP because we had to procure an entire new cloud just to implement it. So that are the environmental factors that you need to consider before you make your decision. Even though you're with Kafka, but you might be with AWS or some other cloud or some other tool. Like, for example, RabbitMQ is much easier to deploy and to implement versus a Kafka. So if your entire ecosystem is more suitable for that, then you might want to deploy and maintain a RabbitMQ versus a Kafka. So that's why we cannot just say, okay, all these features and this tool is what I would use, but you need to consider your real world scenarios before you make your choice.
Thanks.
Yeah, my question is, when you explained that you are using CHAP framework, in one of the slides, you also mentioned that when comparing Kafka with other SQS, you use the point system. So out of 5, you gave 4 and 3. So on what points that you decide that it should be 4 or 3 or so? Is there any industry standard questionnaire?
No,
or
it is not industry, it is on your relative understanding. And that's where you would talk to your business, because you would work collaboratively with your business to understand what is most important for them. And you would, of course, have to reason out with them that why this is more important. For example, if you see cost is rated 9, because one of the major factors for our business was you're spending a lot of time on operational overhead and you're not giving us new features. So please reduce the cost. That was one of the major factors. They were okay that there were minor delays. So that was rated relatively, with cost, it was relatively lower, 6. That's how you would need. It's relative. It's more like the story pointing that you would do.
So it might differ by the company.
Yeah, it differ for what your business really needs.
Thank.
So with Kafka, right, like the only problem we saw was there were multiple retry topics and there were some operational overheads, obviously. Like it is optional to use retry topics. We can directly put it on a DLQ always, right? If we make that small tweak, it is almost identical as to what we have SQS.
Yeah, that's a very good question. So what you're talking about is a blocking retry, where you just block the main topic and you keep retrying. But we also had an NFR where we had to ensure that every label, or 99% of the label, is generated within 5 seconds. So if you do that, then that NFR kind of gets a hit, because you would keep trying, and then the labels which are in your subsequent queue would get delayed even more than 5 seconds. So that's why we had to create multiple topics, so that we can free this main topic, which can continue processing the rest of the events, and we will be reprocessing from the other topics that we had below.
Okay. Do you mean blocking retry is a default feature of Kafka which you can't override?
So there's nothing default in Kafka. Everything is configurable.
Yeah.
It is the way you implement. In our case, we didn't want to implement blocking retries because of the NFR we had.
Okay. Yeah. Thank you.
Hey, love the talk. I love the golden hammer analogy that you're using. In your experience, can you share some other golden hammers that you've seen that you should be wary of? Like one I know is microservices for everything. What are some other golden hammers that you'd like us to watch out for?
Nothing coming to my mind currently. Maybe we can take it offline. Thank you.
Anyone else with a question? All right, thank you so much, Sneha. Please give you a round of applause.